We have looked at how to compute the derivative of the sum of two functions, g of x plus h of x, but now we will learn how to compute the derivative of the product of two functions, g of x times h of x. Recall our definition of the derivative. F prime of x equals the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Consider the example f of x equals x squared times 2 to the x. Notice here that f of x is the product of the two functions x squared and 2 to the x, where we can compute the derivative of x squared using the power rule to get that the derivative of x squared is 2x, and we can compute the derivative of 2 to the x because we know the derivative of exponential functions, and we can find that the derivative of 2 to the x is the natural log of 2 times 2 to the x. But how will knowing these two things help us in computing the derivative of their product, x squared times 2 to the x? Before we do this example, let's look at f of x equals g of x times h of x in general. Using the definition of the derivative and replacing f with g times h, we get that f prime of x is the limit as delta x goes to 0 of g of x plus delta x times h of x plus delta x minus g of x times h of x all over delta x. We will now make this fraction very messy, but it will come out clean in the end. We will add 0 in a clever way, as negative g of x times h of x plus delta x plus g of x times h of x plus delta x. Notice that we are just adding and subtracting the same term here, even though it makes things a bit messy. Now we will split our fraction in the numerator to have the limit as delta x goes to 0 of g of x plus delta x times h of x plus delta x minus g of x times h of x plus delta x all over delta x plus g of x times h of x plus delta x minus g of x times h of x all over delta x. The reason that we do this is because now in our first fraction we can factor out h of x plus delta x, and in our second fraction we can factor out g of x. So we have the limit as delta x goes to 0 of g of x plus delta x minus g of x all over delta x times h of x plus delta x plus g of x times the fraction h of x plus delta x minus h of x all over delta x. Now let's clean this up, looking at it piece by piece. As we take the limit as delta x goes to 0, we have that g of x plus delta x minus g of x all over delta x is simply g prime of x. And also looking as delta x goes to 0, we have that h of x plus delta x is simply h of x, because delta x is going to 0. Next we have g of x, which doesn't involve delta x at all, so it simply remains g of x. And in our last piece, we have h of x plus delta x minus h of x all over delta x, where delta x is going to 0. This is simply h prime of x. So what we found is that the derivative of f with respect to x is g prime of x times h of x plus g of x times h prime of x. So we get that the derivative of a product of functions is g times h prime equals g prime times h plus g times h prime. Or in different notation, the derivative of g of x times h of x is the derivative of g times h plus g times the derivative of h. Using this, we can now go back to our example and compute the derivative of x squared times 2 to the x. We already saw that the derivative of x squared is 2x, and the derivative of 2 to the x is the ln of 2 times 2 to the x. Using our newly found product rule, we get that the derivative of x squared times 2 to the x is the derivative of x squared, which is 2x, times 2 to the x, plus x squared times the derivative of 2 to the x, which is the natural log of 2 times 2 to the x. Let's use this to look at another example. Say we want to compute the derivative of x cubed times the natural log of x. Notice this is the product of two functions, x cubed and the natural log of x. So we can compute its derivative as the derivative of x cubed times the natural log of x plus x cubed times the derivative of the natural log of x. Using that the derivative of x cubed is 3x squared and the derivative of the natural log of x is 1 over x, we get that the derivative of x cubed times the natural log of x is 3x squared times the natural log of x plus x cubed times 1 over x, which can be simplified as 3x squared times the natural log of x plus x squared. In our final example, let's compute the derivative of e to the x times 1 over x, which is the product of the two functions e to the x and 1 over x. So we can compute the derivative as the derivative of e to the x times 1 over x plus e to the x times the derivative of 1 over x. To compute the derivative of 1 over x, it will be useful to write it as a power of x, which is x to the negative 1. Now we can compute its derivative using the power rule as negative 1 times x to the negative 2. And we also need to use that the derivative of e to the x is e to the x. So we get that the derivative is e to the x times 1 over x plus e to the x times negative 1 x to the negative 2. Simplifying this, we can rewrite it as e to the x times 1 over x minus e to the x times 1 over x squared. We can end the problem here, but it's sometimes useful to add our fractions. To do that, we need a common denominator. The first fraction we can write as x times e to the x over x squared, multiplying top and bottom by x, and the second we can write as e to the x over x squared. Then combining these, we get x times e to the x minus e to the x all over x squared. Notice that in these last few steps, we were not doing any work in computing the derivative, simply writing our derivative as one fraction.